Hello guys, it is research series, and in this session I want to learn you how to perform two-way ANOVA. Technically, you can use two-way ANOVA to simultaneously measure the effect of two qualitative features on one quantitative feature. When you're using one-way ANOVA, you are just measuring the effect of one qualitative feature on another quantitative feature. For performing two-way ANOVA, there are some conditions. First of all, you must have a normal distribution in the quantitative feature. For example, assume that I want to measure the effect of sex and pain score, which has been reported as a qualitative feature, on depression, which has been reported as a quantitative feature. So depression must have a normal distribution pattern in this study. Second, there must be a homogeneity of variances in the quantitative feature. And third, there must be no significant interaction between the two qualitative features, sex and pain. First of all, I measure if there is a normal distribution pattern in the depression group. I choose analyze and then descriptive statistics and then explore. I send depression here. We can choose it and then send it here, and you choose the depression, the quantitative feature, and send it to the dependent list. And factor list means the qualitative features which are marking your groups. And then I choose options and plots. In plots icon, you must choose the histogram and the normality plots with tests if they are not chosen, and then continue. And you can also choose, for example, descriptive statistics here, and I finally OK it. So based on a headache group, as a skewness value of between -1 to +1 is considered a normal distribution. Patients who had never, sometimes, or often headache, that normal distribution in their depression score. And there are also other tests, Kolmogorov-Smirnov and Shapirovic test. Both of them have a p-value of more than 500, and it shows that my dataset has a normal distribution. And based on depression, histogram, I can say that there is also a normal distribution. We can, for example, click on the chart and choose this icon. A line appears here like this, and it is typical for a normal distribution pattern. Also, the stem and leaf plot shows a normal distribution pattern with most of data locating in the middle of the chart, and it is the same in all groups. The QQ plot shows that all dots are located or near the middle line, which means that my dataset has a normal distribution. Similar pattern is observed in all groups. So I have a normal distribution and my first condition has been met. So I go for other steps and I choose analyze and then general linear model and then univariate. I want to show it in U, and fixed factor means the qualitative features, and you send headache and sex into fixed factors, and dependent variable means the depression score. I want to measure the effect of headache and sex on depression. I choose model to measure the interaction between pain and sex. It is usually on this mode. You can choose build terms, and then by keeping the control key you can select pain and sex simultaneously and send them here. This icon must be on interaction mode, and I also choose each one of them separately and then continue. I want to choose a post hoc test to measure, for example, which one of the subgroups are different from each other. I choose pain and sex and send them here, and I choose bone frowny test and then continue. There are also other options here. You can choose homogeneity tests to measure if the second condition, I mean the homogeneity of variances, exists or not. There are also other options, for example descriptive statistics, estimated effect size, and observed power, which I don't need them here. And then I click continue. I begin from the above, and there is a Levin test which shows that my dataset in the depression group has homogeneous variances between groups. All p-values are more than 500. So my second condition has been met, and I go for other processes. In tests of between subject effects, I first look at this row, the interaction between pain and sex, and I can see that the p-value is non-significant, and I can conclude that there is no significant interaction between pain and sex. As the simultaneous analysis of pain, sex, and their interaction can affect the p-value of pain and sex, I must remove this row from this analysis and run it again. I close this window and I choose analyze and then general linear model, univariate, and I choose model, and I remove the interaction between sex and pain, and then continue and OK. Now I can see that both pain and sex can significantly affect the depression score, and then I go to post hoc test to see which one of groups are different from the other groups. As you can see, the post hoc has just been performed for headache, because there were 3 moods for headache: never, sometimes, and often, but sex has two moods, male or female, and if there is a significant change, I don't need a post hoc analysis. When comparing the groups, I can see that patients who had never headache are significantly different from patients who often had headache in their depression score. Also, patients who had sometimes headache are significantly different from those who often had headache in their depression score. You can see an asterisk here, or you can look at the p-values, and this p-value are significant, and you can report it easily in your article. If you enjoyed this video, please don't forget to like, subscribe and comment. See you soon.